Decoded.
Welcome to Book Decoded. Ever looked at a tree and just thought, well, yeah, it's a tree standing there? Get ready to completely rethink that. Today, we're diving into Laurent Tillon's incredible book, Being an Oak. Tillon, he's a biologist, but he spent years really getting to know one specific oak tree. And what he found, it's kind of mind-blowing. Forget about passive plants. Trees are dynamic, they communicate, they're incredibly complex. And well, this deep dive is your shortcut into their secret dives.
Right, and it really centers on this one particular oak, which Tillon develops a real connection with. It's ancient, born around 1780. He calls it Quercus, which interestingly means beautiful tree, solid as a rock. And this single tree becomes our window, really. It shows us that nature isn't just scenery. It's full of individual stories and complex details if you just take the time to look closely.
Exactly. So it's not some dry textbook. The science comes alive through Quercus's story, and it reveals trees aren't just, standing there. They're actively engaging with the world in ways that sound almost like science fiction.
Totally. I mean, take just moving water. An oak can pull hundreds, maybe thousands of liters of water a day, way, way up its trunk, completely defying gravity. It uses physics, sure, osmosis, capillarity, stuff you might remember from school, but the real engine is evapotranspiration happening in the leaves.
Evapotranspiration. Okay, wait. That's basically the tree sweating, isn't it?
Pretty much, yeah. As water evaporates from the tiny pores in the leaves, it creates this tension, this continuous pull. It yanks the whole water column up right from the roots. It's this huge, constant process, and it's all powered by sunlight. And those leaves, they're not just solar panels and sweat glands. The book shows they're also really sophisticated chemical factories and communication hubs, too.
Okay, chemical factories, that makes sense for photosynthesis. But communication hubs, what does that even mean?
Well, it's fascinating. If a leaf cell gets attacked, say, by a caterpillar munching on it, it doesn't just sit there and take it. It can send these rapid electrical signals, almost like a nerve impulse in an animal, through the tree's sap. The book even mentions this might momentarily ionize the air around the tree, maybe a very subtle signal. It's like an internal alarm system, getting the rest of the tree ready to defend itself.
Electric signals? Through sap.
That is genuinely wild. Okay. And this internal system, that connects to something even more amazing underground, right? The famous network.
Absolutely. The mycelial network. You can think of it like the forest's own internet. But instead of just sending data, it's a living web that exchanges actual physical stuff, resources. Miles and miles of these tiny fungal threads linking tree roots, often connecting different species of trees even.
So they're literally sharing food and water through this underground system. It's this constant give and take, a mutually beneficial trade. The fungi get shivers, food made by the trees through photosynthesis. And in return, the fungi are much, much better at reaching out and grabbing water and minerals the tree roots can't get to easily. But what's really amazing is that this network also carries those warning signals we talked about. If one tree is under attack, the fungi can pass that message along the network to its neighbors, giving them a heads up, basically, so they can boost their own defenses before the threat even arrives.
Wow, a collective defense system run by fungi. That's incredible. Speaking of defense, what other surprising tricks do trees like Quercus have?
Oh, they've evolved some really clever strategies. There's something called masting. Oaks will coordinate to produce a massive amount of acorns, but only every few years. They time it using subtle cues, like spring temperatures. This huge flood of food totally overwhelms the predators, like mice and jays, so some acorns are guaranteed to survive and grow. Clever, huh? They also delay their budding sometimes to avoid damage from late frosts, and they deploy complex chemical defenses in their leaves to make them taste bad or even toxic to insects. These aren't just passive things, they're active, adaptive responses.
It really builds this picture of trees constantly interacting, adapting, not just with other plants and animals, but with us too, right? The book touches on our long, often complicated history with forests.
It does, yeah. Centuries of logging, of exploitation have really changed landscapes dramatically. But the book also finds some nuance there. It notes that even really destructive events, like huge storms that knock down lots of trees, aren't necessarily purely bad in the grand scheme of things.
How could a devastating storm have a positive side? That seems counterintuitive.
Well, because when big trees fall, they create openings, gaps in the canopy. Suddenly, sunlight hits the forest floor where it couldn't before. This allows different kinds of plants to sprout and grow. And those new plants support different insects, different animals. The dead wood itself becomes this thriving micro-ecosystem. For some rare species, maybe certain salamanders or lizards that need those specific damp, sun-dappled spots, storm damage can actually create vital new habitat. It can increase biodiversity in unexpected ways. It's a good reminder that nature's resilience often operates on, much longer timescales than we usually think about.
It sounds like everything is just happening all at once for the tree. The internal stuff, the underground connections, the defenses, dealing with fungi, humans, weather. It's not just one organism. It's like a central hub in this incredibly complex system.
Precisely. You've got the forest floor teeming with decomposers, breaking down old leaves. Those nutrients get fed back to the tree through that fungal network. The tree makes new leaves, which are eaten by insects. The insects' droppings then feed the decomposers. It's a cycle. And then you have predators like owls keeping the mouse population down, which affects how many acorns survives. It's this constant dynamic dance where every single part plays a role. The oak isn't just part of the system. In many ways, it's orchestrating it.
Yeah, what's so fascinating here is how being an oak just shows Quercus as, well, so much more than just a tree. It's this ultra-connected being, deeply woven into this complex, busy forest community. We've touched on that amazing underground network. How trees share resources, warnings through the mycelium. It's like an internet, but exchanging actual molecules, too. We've seen their clever defenses, chemical warfare, electrical signals always adapting to threats like caterpillars or climate shifts. And we mentioned the long story of humans and forests and how even things like storms, surprisingly, can create opportunities for biodiversity. This whole dive just shows that really paying attention to the quiet life of a tree can give us these profound insights into nature's resilience and the incredibly intricate web of life that's all around us. So thinking about all that, what really stands out to you about the secret life happening inside the bark of a tree?